What is up, guys? Today we're going to continue on with our series in sigma notation, particularly how to come up with these partial sums more quickly than having to do 2 plus 3 plus 4 plus 5 plus 6 plus 7, because some of these will have a lot more terms. It's going to take too long to do in the calculator. But before we go into that, let's go ahead and do the bell work first. So our first question in the bell work is list the next two terms for a sub 1 equals 5, a sub 2 equals 7, and then we have this little formula that says a sub n plus 1 equals a sub n minus 1 plus 5. Well, let's go ahead and list our first two terms. So that would be that's erasing. That would be a sub 1 equals 5. We would have a sub 2 equals 7. Nailed it. We're part of the way there. Now, to get our next term, we have a sub 3. Well, if we look at our term that we want here, we have a sub n plus 1. So we need to turn it into a sub something plus 1. Well, that would give us a sub 2 plus 1. Well, that would make my n, if we look at my n here, that would be that 2. So our n value is now 2 in this equation. So that would be a sub 2 plus 1 is now going to equal that. Instead of a sub n minus 1, we're going to fill that 2 in. It'll be 2 minus 1 plus 5. Well, that's going to be a sub 1, which is right here. So it is going to be 5 plus 5, which equals 10. In other words, if we looked at it in kind of plain English, if we looked at a sub n plus 1, well, a sub n minus 1 would be 2 less than that. If n was 2, 2 plus 1 is 3, and 2 minus 1 would be 1. So in plain English, it's saying the term that I want is 2 terms back plus 5. So we could have done that for a sub 3. Let's do it for a sub 4. A sub 4 would go 2 terms before it would be 7, plus that 5 would give me 12. But feel free to do that whole addition thing like we did in a sub 3, or if you can look at it in plain English, it makes it a little easier and quicker just to go 7 plus 5. All right, the next one says write the series in summation notation. That means we have to put our sigma. So we're going to have a sigma with an index on it. In order to do that, our hardest part is really coming up with an equation that replicates this negative 1 plus 1 half minus 1/3 plus 1/4. Well, start off with, I'm going to make that negative 1 over 1 because I do see that everything has a denominator, so let's make that a denominator. Now, if we look at our denominator, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is, in fact, going to be an arithmetic sequence. When dealing with an arithmetic sequence that goes from negative to positive to negative to positive, so we are going negative and positive. We're alternating negative and positive. We are going to use negative 1 to the nth power. And I know what power to put it to because my first term, which is that negative 1, needs to be negative. So when I plug a 1 in for this n, it should be negative. And negative 1 to the first would be a negative 1. So I do want to use negative 1 to the n versus negative 1 to the n minus 1. All right, so that takes care of our alternating. So now I'm just looking at the sequence that goes 1 over 1, 1 over 2, 1 over 3, and 1 over 4. Particularly, I'm looking at their denominator. The denominator goes 1, 2, 3, 4. Well, that's adding 1, adding 1, adding 1. So it is an arithmetic sequence where our first term equals 1, and our common difference is going to be plus 1 because it's adding 1 over and over and over. So that means that our equation, just for our denominator, note we're just doing our denominator here, is, in fact, I'm going to write this in blue to match that blue denominator there. So we'll have a sub n is going to equal our first term, which is 1, plus our d value, which is 1 times n minus 1, which we can rewrite as just 1n. 1 times negative 1 is negative 1 plus 1 is 0, so it's n plus 0. In other words, it's just n. So our denominator is just n, but that is not our full equation. Remember, our full equation needs to have that negative 1 to the n, and it also has to note that there is a 1 in our numerator, which we'll all put together in this Riemann sum thing. All right, so we're going to use a summation. And to do the alternating -1 and +1, we're going to have a -1 to the n. And now our equation is going to be 1 over n. That will make my alternating, or my denominator go 1, 2, 3, 4. My numerator is always 1. So anytime we have a fixed number, we just leave it fixed. So if that would have been 2 over 1, 2 over 2, 2 over 3, 2 over 4, that one I just circled would become a 2. Well, we start with a first term whenever we're creating this. So let's make this n equals 1. And how many terms do we have? Well, we have that dot, dot, dot on the end, so that means we're going to go on forever. So we're going to put an infinity symbol, and there we go. Now we have our summation that would match that. -1 plus 1/2 minus 1/3 plus 1/4. And if you don't believe me, go ahead and plug in 1, then plug in 2, then plug in 3, then plug in 4, and make sure it matches. In fact, if I was on a test, I'd make sure at least a couple of those work. All right, the next thing we're going to talk about is Carl Gauss. Now, this isn't necessarily a true story, and you can go ahead and read it, but basically Gauss was being punished for misbehaving in class, and the teacher said he had to add the numbers 1 through 100, and until he's done, he has to sit in the corner. Well, apparently Gauss sat in the corner and just thought for a couple of seconds, and then came back and said it's 5,050. And at which point the teacher had to do his or her own calculations, adding it up, which took a while, and it turned out that Gauss was correct. It was 50-50. When asked how he did it, he just recognized that there are a bunch of pairs between 1 through 100. So if you look at this, how these are all matching up, if we match up 1 and 100, that's 101. 2 plus that 99 would be 101. 3 plus that 98 is 101. 4 plus 97 is 101. 5 plus 96 is 101. 6 plus 95 would be 101. It's just a whole bunch of pairs of 101. So what we're actually trying to do is notice that we have 50 pairs times 101 equaled 5,050. So all he had to do is multiply 50 times 101. Obviously, he had to make sure, he had to understand that these pairs existed and how many pairs there were. But he came up with all of that, which creates a very quick way to do arithmetic partial sums, because this is a partial arithmetic sum. This is 1 plus 2 plus 3 plus 4 plus 5, where our common difference is just 1. If our common difference was 2, it would be 1, 3, 5, and we could use the exact same process. So the whole goal is to come up with this pair and then multiply it by how many pairs we have. Well, depending on the information we have, we can use either one of the following formulas to match what Gauss did. And that is, if we have S sub n, so that's the sum, that is looking for my sum of some sequence, where n is the number of terms. Well, S sum n, the sum of all of our terms, is going to be this equation where we do the number of terms we have divided by 2. Then we're going to multiply it by just kind of what Gauss did, where we did that 1 plus 100. Every pair is the same. So if we just take our first number and we add it to our very last number, which I don't know what it is, it'll just be A sub n. That's going to hold the place of our last term. Then we're going to have the sum. So if we look at Gauss's numbers, 1 through 100, we'd have 100 terms. So we would put 100 in for that n. We'd have 100 divided by 2, which equals 50 pairs. My first number was 1. My last number was 100, so it's 50 times 101. The other equation you can use, we're not going to really use this. We're going to primarily just use that first one. We can use n divided by 2 is going to be 2 times my first term, plus our common difference times n minus 1. Now, the reason why we're not going to use this too much is you really don't need to. If you know all this information, you can get your last term pretty easily. This one is just if you know your common difference and the number of terms, you can plug it in here. But generally speaking, we can always get our last term. And it's just one more equation to memorize. So we're going to really focus on that top one, that n divided by 2 times a sub 1 plus a sub n. Plus, that helps us, if we can remember that Gauss thing, that it's just pairs, counting your pairs, and then do your first plus your last, and you will know how to do your arithmetic partial sums. All right, let's do some examples. So in this example, we have 40 37, 34, 31, 28, 25, and 22. So the first thing we should do is recognize that it is arithmetic, and it is in fact arithmetic because we'd be subtracting 3, subtracting 3, subtracting 3. So it is in fact arithmetic. So then we can use this sum formula. This only works for arithmetic. All right, so it's arithmetic. Let's figure out how many terms we have. We have 1, 2, 3, 4, 5, 6, 7 terms. Instead of writing 7 terms, we're just going to set our n equal to 7. So that's our number of terms. Now we just need to plug it into our equation. Well, s sub n is going to be s sub 7, saying that I'm doing the sum of 7 terms. It is going to equal those 7 terms divided by 2 times our very first term, which is 40, plus our very last term, which is 22. And that's going to come out to 217 if you do the math. Our next one is integers 1 through 35. It is in fact arithmetic because just like 1 through 100 is just adding 1 over and over and over again. Well, here's the thing. We just need to know how many terms there are and what our first and last numbers are. Well, we know what our first and last numbers are. It's 1 and 35. So we just got to figure out how many terms there are. Well, we know our first term, a sub 1 equals 1. So just using that logic, a sub 35 is our last term, must equal 35. And it makes sense. There's 35 numbers between 1 and 35. So that means my n is going to equal 35. So we're going to do s of 35 terms. I'm adding 35 terms, which means we're going to take our number of terms divided by 2. We'll take our first plus our last, and that's going to equal 630. All right, so that's long and short of how you do those partial sums. Now let's step it up a little bit with a summation formula. So the only thing we need to know is our first term, our last term, and how many terms there are. Well, to go from 1 through 15, if we count how many terms there are, there's 1, 2, 3, 4, all the way up to 15. So there are, in fact, 15 terms. If you start at n equals 1 all the way to I equals 15, there's going to be 15 steps. So that means there are 15 terms. Now I just need my first term and my last term. Well, my first term would be a sub 1. That would be plugging a 1 in for my i's. So that would be 3 times 1 minus 5. 3 times 1 is 3, minus 5 is going to be negative 2. Then we need our last term. Our last term is when we plug in 15, so that would be a sub 15. So that's going to be 3 times 15 minus 5. And that's going to go ahead and equal 40. 3 times 15 is 45, and 45 minus 5 is going to give me 40. All right, so that means my summation, I am using 15 terms, is going to equal 15 divided by 2 times my first term, which is negative 2, that's okay, plus that 40 is then going to equal 285. All right, if we look at our next one, it doesn't look that out of the ordinary. We're adding 5 over and over and over, so it's arithmetic because it's plus 5. It's plus 5. It's arithmetic, so I can use this summation formula. Here's the problem here. I know what my first term is. I know a sub 1 equals 36. I do know my last term is 91, but I have no idea how many terms there actually are. There's that dot, dot, dot in there, so I don't know what n equals. And I don't know what a sub n. I know it equals 91, but I don't know what term that actually is. So we need to find how many terms there actually are. Now, you could make a whole list and go, okay, it's plus 5, plus 5, plus 5, and count them all out. But instead, I'm going to come up with a formula, and I'm going to go ahead and solve it. So we're going to come up with the explicit formula for this arithmetic sequence. And that is, I need to know my first term, I need to know my common difference, which is 5. And then we can come up with a nice arithmetic sequence that would be a sub n equals my first term plus my common difference times n minus 1. Simplify that down, we'll have a sub n is going to equal 5n. 5 times the negative 1 is negative 5, plus 36 is going to be plus 31. Well, now what we're going to do to solve this is I know what my very first term should be. I know a sub 1 should equal 36. And I also know what my last term should be. It should be 91. So when I plug a 91 in for this a sub n, it's going to equal 5n plus 31. Well, that means I just need to solve for that n. And if I subtract 31, I divide by 5, we'll come up with n equals 12. So now I know what this n is, and I also know what this little guy is here. So now we can do our summation, or our sum. So our sum of all 12 terms is going to equal the number of terms divided by 2 times my first term plus my last term, and that's just going to equal 762. All right, the last thing we're going to do is just a word problem that's going to use an arithmetic sequence in it. It says, find the total salary for an employee who is paid $20,000 the first year and receives $1,200 raise each year for the next 39 years. So this is definitely an arithmetic sequence. Every single year, they get 1,200 added to it. So it's a sequence that goes like 20,000, 21,200, and it's just going to keep adding that 1,200 each year. And that's 39 years. So that means we're going to talk about 40 terms, because we start with 20,000, and the 39 years after that, we actually have 40 different salaries. It also says find the mean of the 40 annual salaries. So we're supposed to find the total salary for this employee that was paid $20,000. So yes, we could go on our calculator and write $20,000 plus 21,200 and just keep adding and adding and adding until we get to 39 years later. But that's going to take a whole lot of time. So what I'm going to realize, it is arithmetic. It is, in fact, arithmetic. And I do know my first term is going to be $20,000. And I know that the common difference in this case is going to be 1,200. Well, all I need is the first term and our common difference, and I can come up with an equation for my given sequence. So we'll have a sub n equals my first term, which is 20,000, plus my common difference, which is 1,200, times n minus 1. Well, we can simplify that down to 1,200 n, and then we're going to have plus 18,800, yeah, 18,800. So that's the formula for my arithmetic sequence. And the reason why we're coming up with this is because I need my first term, my last term, and the number of terms we have. Well, we have 40 individual salaries. Remember, even though it says it keeps adding for 39 years, we do have to count its original salary. So we know what our n is. We know our n is going to be 40 because we have 40 individual salaries. So we're going to do a sub 40 to look for my last term. All right, well, that means we're just going to plug 40 into this equation we just had down below. So we're going to have 1,200 times 40 plus that $18,800. That's going to equal $66,800. Now note, this isn't what they finally get, that's just their last salary. We now need to come up with the sum from first year to last year of how much they actually made. Well, that summation formula is just the sum of those 40 salaries is going to equal the number of terms we have, so that's 40 divided by 2, times the first year's salary, which is 20,000, plus the last year's salary, which is 66,800. And we are going to come up with $1,736,000. So that's how much that person made over that 40 years they worked there. The last thing we're supposed to do is come up with the mean. Well, the mean is just going to be what we had. So it's going to be our total divided by how many years it took to do that. So an easy way to put that is our average, which is just x bar, that just stands for mean, is going to equal the total amount of money they made, S sub n, divided by how many years it took them to make that much money. In this case, we're going to have that $1,736,000 divided by the number of salaries they had was 40 years, which is just going to equal, they made on average $43,400 per year. So that's our total for our total, and then we come up with our average. All right, guys, that's about 20 minutes. Make sure you have this done. Remember, the actual homework is not due. You're going to have a work period whatever day we come back, whether that be Thursday or Friday. All right, guys, stay warm.